Color guard, a sport that is known for its grace, athletic prowess, and need of limber brain as well as coordinated muscles of the athlete. It takes hours of training of both the mind and body to achieve the amazing feats of artistry that only the best of the best are able to master. Strength is needed not only in the throwing arm, but the entire body. Not only does the body and mind need to be focused and devoid of distraction, but the power of physics is needed to be on the side of the athlete as well. It is when these things converge, time, energy, practice, skill, concentration, and physics, that true art is made. There are many tricks that a color guard is able to do. The lasso, the parallel, the fan toss, the 1.5, and the double. All these tricks rely on the ever-powerful centripetal force. Centripetal force is a physical phenomenon that as an object spins, its acceleration is inward and the velocity is constantly changing its direction. For our first experiment, we used a 6-foot flag in order to find the centripetal force of a double toss. The centrifugal force formula is mass times velocity squared divided by radius. The radius of our pole was 0.91 meters. We then had to make a circle using the whole flag as the diameter of the full rotation of the flag. The circumference added up to 5.7 meters. This times the time of one rotation, which was 0.72 seconds, equals the velocity, which is 7.9 meters per second. We also found the mass of the flag, which was 0.998 kilograms. So that would mean the mass, 0.998 kilograms, times the velocity squared, 7.9 squared, divided by the radius, 0.91, would give us our answer of centripetal force, which came out to be 68.1 newtons. After finding the centripetal force, next we wanted to calculate torque. Torque takes 3 equations to calculate: angular velocity, angular acceleration, and moment of inertia. For angular acceleration, it's the final angle minus the initial angle divided by time. Since it was a full rotation, it's 360 minus 0 over 0.72 seconds. Next, we have to convert the angle into radians, which is 2 pi, divided by 0.72 seconds. And we find that the angular velocity is 8.72 radians. Next, we have to find the angular acceleration. Angular acceleration is the angular velocity, 8.72 radians, divided by the 0.72 seconds. And this equals 18.1 radians per second. Next, we need to find the moment of inertia. The moment of inertia for a pole is I equals 1/12 times mass times length squared. In our example, it's 1/12 times 0.998 times 1.83 squared, which equals to 0.279. Finally, we arrive at torque, which is the moment of inertia, which is 0.279 times the angular acceleration, which is 12.1 radians per second squared. And thus we finally arrive to torque, which is 3.38.